G'day, back doing a bit more of the Taylor Hobson rotary table today. I sort of stopped because I couldn't quite work out what the next step was, and so also thought I had to make up some tools, which I did, and then it turned out that those tools wouldn't work in the way I wanted to in the first place. So anyway, I've overcome that, so I've now refined the bore on the base and made up the clamping nut and all that sort of thing, and that should push me on a little bit further with that project. One of the reasons I'd left the Taylor Hobson rotary table for a while is because I'd plunged in here with a cutter which on the face of it said 5 inches, and I didn't check when I bought it. I just assumed it was. Someone had resharpened it down so it was a little bit under. So these grooves don't fit the bit that sits on there. So one of the things that I have to do is actually recenter this, and this is where it gets a little bit nasty, because I don't know. I've got an undercut to get into here, so I need to set it up like this. I can't just sort of sit it there and find it with a boring head. I'm going to have to do it on the rotary table so I can get a cutter of a decent size in there. But I've set this up on the rotary table. This is my larger angle plate. Right now I think it's wonderful it doesn't have webs on the back, because I've actually got this on the reverse of it and holding the plate down here. I've actually run out of Z, and in fact this is what the 00 was made for, was to try and get this centered, but I can't use it because that sits down here somewhere. So I've gone into my box of bits and found an interrapid indicator with a funny little stalk thing, and I'm going to try and set that up. So this is how I finally got the part dialed in. I started off with a DTI in the spindle. That didn't work all that well because I just couldn't get the range of adjustment. So instead of having a rotating indicator and a stationary part, I went for a rotating part and a stationary indicator. The rotary table is on the spindle center line, and so I can rotate this round, and it's all good. I've got this within 0.05 of a millimeter. I could possibly get better, but the setup is dodgy enough as it is, so I'm going to leave it as is and just work with what I have. All I really want to do is get a cutter in that I can thin this down a little bit, dress this back a little bit because that's a little bit high, and then take this radius out a smidge. I'm not quite exactly sure what, but I'll see when I get the cutter in there what I need to do. So this radius is to size, and that one is. I made a note of where the DRO said I was, and took the cutter in the same amount there, so that's all good. This bit here, unfortunately, is a smidge too thick. It should it should be an almost size for size fit in the swivelly bit. I've got 0.15, 0.2 clearance between there and there. The original has got nothing, or nothing that my feeler gauges can pick up, so I'll have to do something with that. I might have to put some shim in there or something like that to get that back to where it should be. The next thing I'm going to try and do is put these lumps and bumps in here. Now these ones here are only for guidance, right? These ones here have the locking bolt sitting between them. So what I'm going to do is just use a cardboard template to work out where these things are, and just cut them in there. I don't think there's any need for any great precision there, and I can always come back with a file and trim them up if I find I'm in the wrong spot there. These ones here have got a bit of draft, so they're not even sitting there. I think they're just basically a stop for the angled travel. So I might leave those a little bit long and tune them to suit, but the stop is an eccentric bush anyway, so it'll probably be quite all right. I'll be able to adjust for that, but it's just a matter of putting in the, you know, those sort of radii while I've got everything set up and I'm doing radii. So there's just a bit of a card. I've marked the original positions there. I've put that behind, used a couple of marks top and bottom to line up, and then I'll just take that down to the appropriate radii, leaving these bits proud. They're where they should be, and I'm going to come back and tune those with a file. Once this is done, I then get to put the hole in here and make up a draw bolt so I can actually hold the table on, and that will then set me up for machining that top surface. So this wonderful setup will not be needed anymore. Here are the two parts. They nest together and they they move reasonably well. I mean, that's an unpolished surface and all that sort of thing. I need the locking bolt in there to you know, pull this up and all that sort of stuff. But the next thing will be that once I have that locking bolt, I can lock that up. I can, you know, file these stops a little bit better and put some pins in. But the important thing is I can come along and I can machine off that surface, including that, so that when it's properly set up, this surface is going to be parallel to this surface. And that means putting, you know, angular graduations and all that sort of thing. And once this surface is parallel to the surface it's sitting on, I can also then come in and bore out the hole for the turntable, put the turntable in there, and then fingers crossed that means I've got the turntable is going to be parallel with the surface that it's sitting on, and when this is at 90 degrees, the axis of the turntable is going to be vertical. To be able to clamp the table onto the base, Taylor Hobson have come up with this device, which is interesting. One of these screws is just a stop screw, so that you know, don't lose the thing entirely, and the other one is actually the clamping screw, and you clamp on that, and because of the way the casting is drilled, that pulls that down and clamps onto the inside of the groove. Now, as I was saying, when I cut that groove, that's actually a spherical surface that it's clamping onto, so therefore this needs to be a spherical surface. I've got a horrible suspicion that is also spherical, but I think I'm going to ignore that and just put a chamfered surface on there, and if I get that and that to coincide with a decent chamfer countersink, I think that'll work. But to make this part, I've got to put a spherical surface on there of around about, well, it has to be the same radius as the rotating bit, which I think is a radius diameter 50, diameter 100, radius 50. So I'm going to use my ball turning device. I was originally intending to use a bit of square bar to make that nut, but I worked out very quickly that the interrupted cut on the radius turning was not going to help me. So instead I've gone for some round bar, and I'll have to square that up after I finish. Now, I could actually measure where this is and what it has to be, but that's a little tricky because the ball turning device hasn't actually got any graduations on it. What I'm going to try and do instead is just use a cardboard template. This is just something I've traced from the casting, the radius on the casting, and so I'm going to try and get that to match, and that should be good enough to give me the clamping that I'm after. I had to muck around a little bit and change a few settings, but that profile is pretty close, and I'm happy enough with that. I'm now going to get a bit of emery on my felt-backed polishing stick, and just give that a bit of a polish before I then drill a hole through the middle to match the pin. Once I've done that, I can then, well, I can either part that off now, or I can take that over to the mill and put the flats on there and then part it off. I'm now putting the what would you call it, counter bore, countersink, whatever, into the back of the clamping nut or clamping piece. I speculated earlier that looked like a spherical surface, and it is. Now, I haven't got the equipment here to put in a sphere of that size. That looks like it's probably something like, oh, I don't know, 1.5 inch diameter or something like that. So what I've decided I'm going to do is I'm going to make my version of this with a 120 degree countersink, and then when I come to make up the pin that goes in there, I'm going to actually put the spherical surface, or at least a rounded surface, on the head of that, and that should give me, it won't give me perfect contact, but it'll give me, I think, good enough for the way this is going to be used. I've already counterbored the nut here, and I'm sorry, I'm going to keep calling it a nut even though it's not, just because it's nut shaped. Rather than coming in and boring this way, what I've decided I'm going to do is I've got a very small boring bar here, and that'll just fit in there. So what I think I'll do is basically just pull that back like that, and that'll give me the same end effect. I need to be careful that I meet up with my corner there, but apart from that, I think I'll be right. I'm now machining up the drill bolt. There's nothing terribly exciting about that, except that to put the, as I said, I'm going to file a slight radius on that, but to put the basic flat on there, I'm going to use a similar method to what I used before, but because of clearance and all that sort of stuff, instead of using my smallest boring bar, I'm using my largest boring bar. And I'm actually going to be running the lathe backwards. I'm behind it here, and so if I run the lathe backwards, it'll give me the same sort of thing. Now, don't try this if you've got a screw-on chuck, but every so often it's a handy thing to remember that you can run a lathe backwards, and sometimes it enables you to get in there to places you wouldn't normally get to, because if you think about having a tool on the front here, the compound would either have to be over here or over here, or over here, and neither of those is really going to be terribly practical. So this is actually a reasonable way around that issue. There's my finished drill bolt, polished up and thinned down, all ready for putting the notches in. That'll be work for another day because I'm running out of time here. My nut fits on there, and with the slight radius on here and the flat on here, that still gives me a little bit of movement there, so it'll still adjust. And if I put the real nut on, similar sort of thing, and I can even do it the other way with this one, and get that too. So that should work quite nicely. And we just need to notch that. That'll require some machining of the casting, so that'll be another episode. But there we go. Thanks to John Barron for helping me find the and get hold of the collets for the chuck here. It works quite nicely, and one of the problems I have with my 3-jaw chuck is it's quite a nice chuck, but it's got the jaws hanging out, and I'm always a little concerned, particularly when working close to the chuck, that something's going to catch and all that sort of thing. So having a collet chuck like this is very nice. The ER40 collet chuck I've got is good too, but this one, just with the the key type action, is much easier to get things in and out of. So I'm using that for this, and you'll probably see this on another clip or two doing other things, because I quite like it. I had to swap back to the 4-jaw for doing that, but straight back on again. Anyway, thanks for watching. I hope it's been of interest to you, and we'll see you for the next one.